All right, good morning, everyone. Oh, oops. Why echoed? Okay, test. Okay. Good morning, everyone. Last week you finished the midterm, and I will explain that maybe in the second or third class. And now we need to go to the new chapter. That is chapter 4.3, conditional probability, and 4.4, counting techniques. And because personally, I think the importance of those two sections are fair. Remember, if something that is really important, I will remind you, this part is important, you need to understand it, you need to memorize it, all details. I will remind you. Otherwise, this part, for example, the condition probability, personally, I think the importance is fair. It's okay, just okay. So I will just teach the first part, the first exam. And here, suppose you want to figure out, you should buy a new car. When you first go and look, you find you find two cars that you like the most. In your mind, they are equal. So they has 50% of each one. You will pick it up. Then you start to look at the review of the cars and realize that the first car has the 40% chance to be repaired in the first year, while the second car, the percentage is 10. Thus, you can use this information to help you decide which car you want to actually purchase. Okay. By the way, in the future, when you go to the US to your study, let me share my experiences. And here, I don't know what's going with it. And here is the candidate book. I have no idea the updated information, but in the past, this website is the top 1 go-to famous website to introduce the use the car, the price. For example, I used to live in a small town in New York State, and I tried to buy a new used car, not a new car, sorry. And I searched from this website, checked. In the end, I bought the car from our campus. That's a free car, and how can I say that? Retired car. According to the campus regulation, the car can be used no more than 50,000 miles, all 3 years. And actually, the condition was still good, and I bought one. And you can check the candidate book. But I think that was the problem because last year I used this website, and it says access denied. I don't know. Maybe you can use VPN to switch your location to the US, and you can enter this one, or you can use the car prices in the US. I believe there are alternative website you can find here. KBB access denied. Okay, I don't know why. Okay, let's come back here. And here is the conditional probability. Probability calculated after information is given. Okay, after information is given, this concept is important. This is where you want to find the probability of event A happening after you know the event B has happened. Oh, actually, those two sentences is not easy to understand, but when I use the example from this textbook, you will know it. If you know that B has happened, then you don't need to consider the rest of the sample space. Okay, again, as long as you know the event B has happened, then you don't need to consider the rest of the sample space. It means in previous classes, I explained how to list a sample space. For example, if I have 2 dice, I throw 2 dice and there are 12 events. 12 events. Sorry, there are 60. 6 times 6 is 36. Sorry. There are 36 combinations. So that is the sample space. And if I have 2 dice, the first is called die A, the second one is die B. If I know the event A happening, for example, the die A shows number 4, and so what's the probability to get the number 4 from the second dice? That is 1/6. 1 divided by 6. Okay, that is the conditional probability. And event becomes the new sample space, which is called restricted sample space. Okay, let's check it again. Restricted sample space. If the abbreviations are, if you always write the restricted sample space when doing conditional probabilities and use this as your sample space, you will have no trouble with conditional probabilities. The notation of conditional probability is probability, the function, A, after a given B, and you can write it like this. P, parentheses, A line here, and after B. The event following the vertical line is always the restricted sample space. Okay, it means the B is given. It happened first. Then we are investigating the probability from A. But A is based on given B. Get it? Okay, let's check the first example. Example 4.3.1 conditional probability. Suppose you roll 2 dice. What is the probability of getting a sum of 5? Give the first die is a 2. Okay, and let me have mine. Okay, and here, suppose you have 2 dice, and I have 2 dice, and the second one. What is the probability getting a sum of 5? If we ignore the condition of given B, for example, the first die, the probability is 1, 2, 3, 4, 5, 6. And the second die is the same. 1, 2, 3, 4, 5, 6. So the combination is 6 times 6. That will be 36. But now, given that the first die is a 2, look at here. Because the first die that is restricted on the number that is 2. And we go back to the question, how to get a sum of 5? How to get a sum of 5? Now we can calculate. The first one is 2. 2 plus 1. No. 2 plus 2. 2 plus 1. That is 3. 2 plus 2, that is 4. 2 plus 3, that is 5. Yes, this is what we want. And so what's the probability to give a sum of 5? So now please tell me, what is the sample space? How many sample spaces are there in this event? Actually, it is 1, 2, 3, 4, 5, 6. The sample space in the denominator, that is 6. But only one condition fit the criterion, that is here. So only one event can make the sum of 2 dice is 5. So only one. That is the probability. Okay, let me show you the answer from the textbook. Solution: since you know the first die is 2, then this is the restricted sample space. So this is the all events 2, 1, 2, 3, 4, 5, 6. So the restricted sample space, that is R. You can write like this. Where is mine? Oh, sorry, not this. You can write down like this. The R restricted sample space equals braces. You know the braces here. And parentheses 2, 1, 2, 2, and the second brace. Okay. And now the total sample space, restricted sample space, the number is 6. And only one. To make the sum is 5. That is 2 and 3. That's 2 and 3. So the probability sum of 5 when the first die is 2, the probability is 1 over 6. 1 over 6. Okay, get it? Now, please use 1 minute to calculate the second question. Suppose you roll 2 dice. What is the probability to get a sum of 7? Given the first die is 4. Given the first time the die is 4. Okay, 1 minute, please. Okay. Then suppose you have two dice. What is the probability getting a sum of 7 given the first die is 4? Okay, you can use $1 create $1 method. For example, originally the dice has 6 points. 1, 2, 3, 4, 5, 6. The second one, 1, 2, 3, 4, 5, and 6. And now the first die is given 4 as here. So we know the sample space since the first condition is determined. And how many sample spaces? Retrieve sample spaces. 1, 2, 3, 4, 5, 6. For 1, for 2, for 3, for 4, for 5, for 6. Thus, that is 6. And the question is to get a sum of 7. To get a sum of 7, only this combination 4 plus 3 equals 7. Only this one has the sum of 7. Only one condition, only one combination. So the answer is here. Is that okay for you? Okay, let's check the answer from the textbook. Question B. Since you know what the first die is for, this is your restrict sample space and the abbreviation is R. R equals brace, the first brace, for 1, for 2, for 3, 4, and 4, for 5, and then the next pair is for 6. There are 6 combinations, and we wrote it on the we wrote it on the denominator. And here sum of 7, when the first die is given and the number is 4, and in this condition only one condition fits this criterion. That is one condition, only one. Thus, the number of the probability is 1 over 6. 1 over 6. Okay, how about use 1 or 2 minutes to write down these notes on your website, then we can switch to next chapter, next section. And the other part, personally, I think, I will explain this a little bit. Okay, then here. Okay. In the first case, the event of sum of 7 and the first die is 4, and they are called independent events. In the second case, the event sum of 5, when the first die is 2, that is called dependent events. Okay. When events A and B are considered independent events, if the fact that one event happened does not change, again, in fact the one event happens, that does not change the probability of the other event happening. We call it independent events. In other words, event A and B are independent if the fact B has happened does not affect the probability of event A. Okay, that is easy to understand. And thus, probability A after a given B the probability is A or B after A, that is equal to B. They are independent. Let's have an example here. Independent events. Suppose you roll 2 dice and the event sum of 7, when the first die is a 3, is it independent? Again, the formula is here. I don't think you need to memorize this. In the future, you need to come back to check the formula. Suppose you have 2 dice after the event sum of 7, the first die is 3. Is those events are independent? Let's check here. To determine if they are independent, you need to see if the probability A of given B is equal to probability of A. It doesn't matter when the event is A or B, just assign one as A or B. Okay, here, for example, the sum of 7. The sum of 7, the combination is 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. That is the sum of 7. And the event B, the first die is a 3. The first die is a 3. And the combination is 3, 1, 3, 2, 3, 3, 3 and 4, 3 and 5, 3 and 6. So it means it assumes the B has happened. The restricted sample space is B. And we can write like a restricted sample space 3 and 1, 3 and 2, 3 and 4, 3 and 5, 3 and 5, 3 and 6. There are 6 combinations. In this restricted sample space, the way to happen is 3. The pair of 3 and 4. So probability A after given B, that is 1/6. Then probability A, that is 6 divided by 36, is also 1/6. So the sum of 7 and the first die is 3. They are independent events. Okay, get it? This part, I think, personally, I think it's okay. It's fair. It's fair, and you can know this. And next one, in the opposite side, it's called here. Dependence. No, not here. Okay, I think I can skip this one. Okay, go to the next chapter. Next section is chapter 4.4. Here, counting techniques. And in this part, there are some formula. I highly recommend you to remember them. There are times when sample space or event space are very large. It's not feasible to write it out. In that case, it helps to have mathematical tools to count the size of the sample space and event space. There are tools known as counting techniques. Then, definition, multiplication rule in counting techniques. If test A can be done in M1 so many ways, and test 2 can be done in M2 so many ways, and so forth, the test N being done N ways, then the number of the test 1, 2, 3, 4, 5 until the N together will be M1 times M2 blah 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 times the end of it. Okay, let's check an example. A menu of choice of 3 salads, 8 main dishes, and 5 desserts in a restaurant. How many different meals consist of 1 salad, 1 main dish, and 1 desserts are possible. So again. Oh, okay. Let me here. And again, in a restaurant, on the menu, there are 3 types of salads and 8 types of main dishes and 5 desserts. So how many different meals consist of 1 salad, 1 main dish, and 1 dessert are possible? So 3 times 8 times 5. The answer is 120. When 20 different meals, I prefer to call it combinations. So that is the multiplication rule in counting. The second example, how many 3-letter words can be made from the letter A and B and C without letters repeating? A word is just an ordered group of letters. It doesn't have to be real word in a dictionary. Okay, again, so the sample space is letter A, letter B, and letter C. So the first letter, because no repeating, thus when we choose the first letter, the remaining is 2. When we choose the second letter, the remaining is only 1. You have no choice. You need to pick up the last one. So which is 3 times 2 times 1, and that is 6. Let's look at this diagram. It's easier because in the rule there is no repeating words. So if we pick up the first letter, that's A, and the remaining 2, only 2 choices, B and C. We pick up C, the remaining one is C. We pick up C, the remaining is B. So after the combination, that's ABC, ACB. And if we pick up the first letter as B, and 2 possibilities, the first one, A and C, C and then A. So that's BAC, BCA. If we pick up the first letter as C, then the remaining is A and B, B and C. So in the completed events, there are 6 possibilities here. So we know this. Again, the first one, the combination of each one, just multiply them together. But the second one, without the repeating, 3 letters A, B, C, pick up 1, remaining is 2. You have 2 choices. After you get the second one, the last one you have no choice because only 1 letter over there. Okay, now in example 4.4.2, the solution was found by find 3 times 2 times 1, that is 6. Many accounting problems involve multiplying a list of decreasing numbers. This is called the factorial. And there is a symbol, special symbol for this button on your calculator, like this. We read it as n factorial, like this, n times n minus 1 times n minus 2, and times until the next to 1. For example, 5 factorial, that is 5 times 4 times 3 times 2 times 1, that is 120. 8 factorial, that is 8 times 7 times 6 times 5, 4, 3, 2, 1, that is 40320, that is the number. And here is important, 0 factorial, that is defined to be 1, and 1 factorial, that is also 1. That is the definition. Don't ask me, I'm not the scientist who did this definition. Just remember it, And now have a test, Can you calculate this one? Calculate this one. Ten factorial. Could you give me a number? Then 100 factorial. I believe you can calculate this by your pen and paper based on here 40320. You can base on the answer here. But for the 100 factorial, you can use computer applications or your cell phone apps. Okay, 1 minute, you can do this. Sure. In the final exam, I will set the question like this, but just maybe one question or two questions. That is easy, and just type your cell phone on the scientific calculator apps or online application. You can search on Google scientific calculator and type 100 factorial and get the answer. I think you'll be amazing. A big number like this. Okay, do it 1 minute. Oh, okay. Let me show you how to calculate this by pen and paper. Okay, the first, we have the good base at factorial. That's 4. For example here, 10 factorial, that's 10 times 9 times 8 factorial. And we know this part, that is 40320. Then we can continue to multiply. Here, what I will do is like this. Move the 0 here and multiply it by 9. That is I just guess if I do it correctly, it should be 3628800. Okay, and now you can use different way. For example, scientific calculator online. There are many online applications like this. For example, this one is from Google. I think it's from Google, from somewhere. I don't care. Type 10 and click the button here. See, here is a factorial symbol here. Click it. Ten factorial, and the answer is click here. Get it? And my question is, next question, how to calculate clear 100 and press the button of factorial like this, and then click enter. The answer look like this. Horrible. Horrible. So the same rules in the end. Our final exam, students are allowed to use any kind of devices or materials during the final exam. So don't worry about this part. But I encourage you to calculate in the beginning. So now I have a question. Before we take a rest, let me show you. Okay, and here. This question is from YouTube. On the numerator, there is 10 factorial. In the denominator, there is 3 factorial times 8 factorial. So can you see the answer? To be honest, I can calculate the answer in 10 seconds. I'm not kidding, because as long as you understand the rule, you can calculate very quickly. For example, 8 factorial, here is 10 factorial, so what's the difference is here? This one has 2 additional numbers besides this one, because 10 times 9 times 8 factorial. So when we cancel the 8 factorial on the numerator, 10 and 9 are left over there. Get it? 10 and 9. Then, okay, and here is 3 factorial. That is 3 times 2 times 1. We can cancel 3 by the 9, cancel 2 by the 10, and that will be 3 times 5, that is 15. I think this part for someone that's easy. You even don't use your pen and paper to calculate. So let me finish this part, then we can have a break. Because recently the YouTube always show me this kind of question. Let me show. We can write the formula, the question like this. 10 times 9 times 8 factorial. The denominator 10, 8 factorial. 3 times 2 times 1. We don't need to write it. And cancel here. Cancel here. Here's 2. And cancel the 2 factor in 10, that will be 5. So the answer is 15. I know some of you are thinking, oh, what an easy question. I don't think it's a big problem. But some of you, I hate math. I don't like math. Either way is okay, but just so you know, the definition of factorial you need to understand, because in the future when you become a staff in a company, this is the basic part. And I try to teach the basic concept. In the future you can use calculator to do it. Okay, have a 10-minute break, and I will check the attendance later.